How many of you in the room are CHP? Raise your hand. Yeah, small number of us. I'm actually on the part 2 panel. There's a part 1 panel, they do the part 1 questions. There's part 2, we write the part 2 questions, we grade it. It's a yearly cycle that we go through. So I'm here to talk to you about being a certified health physicist and also kind of like my perspective, having been on the board now for 3 years. It's a 5-year commitment. And then sometimes they ask people to stay longer or they ask to stay longer because it's fun, but I don't want to self-proclaim my nerdness to the group. So I'm going to mention a couple products, so I decided to put a disclaimer. Products that I think are good for studying for CHP. So this disclaimer, the products that I mentioned later on in the presentation are my recommendations, nothing to do with the Navy, right? So what does it mean to be a certified health physicist? So it means they met the requirements of studying the health physics profession, and the American Board of Health Physics endorses that person to become a member of the American Academy of Health Physics, a professional organization that's dedicated to the furthering of health physics. So by being a CHP, you've met the professional requirements, which I'll go into, and you also met the immediate knowledge requirements specific to health physics, which is validated by a 2-part exam. And so the third one says what you've recognized and assumed the responsibilities of being the responsibilities due to the profession of health physics. And then you might think, like, what's the responsibilities? And with that, I'll interject. Throughout my presentation, I decided to do a theme of past and present RHOs, so I hope I pick good pictures, but if you're a CHP and you respond with pictures, I really appreciate you. Commander Source, because he didn't want to give me a picture, so he said, no, I don't like how I look in this uniform. So anyway, here's a list of kind of the responsibilities. No need to read off the screen, but it's all about technical competence, right? Obviously, you're certified in health physics, but then it's also that technical competence relays to various, I guess, stakeholders, whether it's the general public or patients that you're treating for in health physics. Like if you're involved in radiation protection, right? You're certified that you're knowledgeable in protecting the patient or staff member who's doing a procedure. Like for example, when I was in Japan, it was really nice being a certified health physicist because the Japanese Nuclear Regulatory Authority immediately recognized the CHP as having weight when I came to the table to do the joint drill. So they do a joint drill every year, and because I was a CHP, they immediately recognized that, so it was real nice. So the value of certification, there's a salary survey that I'm going to go over in a minute, and in conjunction with the salary survey, they ask, like, is it a positive or negative or neutral thing? I believe it said 0% found it negative, it's 7% found it neutral, and then the rest, 93%, found it to be of positive value. And the reasons they found it to be positive were because, oddly enough, it's actually the more professional respect. It's more the professional respect, not necessarily the salary, which is only 50% of the respondents. So that goes in line with job satisfaction. You know, the reason why I'm choosing the post-military retirement job I am is because of the job satisfaction and the quality of life, not necessarily the pay. So that's something to keep in mind. So here's the salary survey. There's 2 salary surveys out there. And I'm not presenting the salary survey to try to convince you to leave the military. You know, I've done my 23 years, and had I left the military early, the companies that were looking to hire me, my post-military job, wouldn't have wanted to hire me because they're hiring my breadth of knowledge, having been to different duty stations in the military, right? So I think there's a lot to be said for staying in the military 20 to even 30 years before you pick up a secondary career post-military, if that's what you want to do. But there's Health Physics Society, and then the ABHP, which is the American Board of Health Physics. They publish these results every year, and the links are at the bottom if you want. This presentation will be available digitally. We'll post it somewhere, or you can Google search it. But pay attention that there's no correlation to the under 6 years experience, and that's because there's no CHPs within 6 years, because that's the minimum amount of time that's required. So what they try to do is they try to have the non-CHPs do the general health physics survey, Health Physics Society, non-CHPs, and then the Certified Health Physicist will do the right one. I don't think many of us want to do 2 surveys for the same thing. Personally, I've abstained from doing the survey because I've never really truly known how to factor in the BAH because it's pre-tax. I don't know if I should include it, shouldn't include it, so just out of nervousness, I've never even done the survey myself. But something I want to cue into here, the values for us, how many have been in the military for over 10 years in this room, right? And so I skipped over the under portion. And even though nuclear, like I'm a prior nuke, my time in doing health physics is under 15 years. So my total time is 6 to 15, but nuclear or teaching as a DIO in power school, that still relates to your experience as a health physicist because you're peripherally involved. And I think it's important to include that, especially on resumes and CVs and stuff. And so you can see here how the number jumps from 123 to 153, right? But if you go to the over 15 years experience, which is where some of the senior lieutenant commanders would be, or people looking at getting out of the military, for all health physicists, the number goes up just a little bit. And then for the people with master's in health physics degrees, the number's about the same. And the reason I mentioned the health survey is I use it as a good transition to talk about where the future of health physics is going. Okay, how many have read this report that came out in 2015 about the future of health physics? You've read it? Okay, you've read it, yeah. So they predicted that in 2015 that not only the staffing of health physics members, whether they're certified or not, the actual staffing is going to decrease over the next 20 to 30 years. And it's not just a national problem, it's an international problem. The ICRP talked about it in Canada and they released a statement in 2021, I think. But it's a serious threat because we're losing corporate knowledge, we're losing interest, we're not able to help the country and our citizens like we're supposed to be doing as professionals because of decreased staffing. And so there's decreasing numbers in students enrolled, there's decreasing number in academic programs. I believe, or I guess it was a medical physics program that one of our RHs went to and they had just decided to close their program. Maybe that's what you were alluding to with the Dunes. They showed up and, oh, by the way, our program shut down.
It was a health physics.
It was health physics, okay. So, in the long term, per the journal article or whatever this was, the future, where are the radiation professionals? They predict that in 10 to 20 years, experienced workers will be retiring. And so we're right at that 10-year point. This, next year, 2025 will be the 10-year point. So I'm looking forward to see where this is going. I just remember doing doings myself at Clemson University, and we went up to Oak Ridge, and we had a trip to the Ortec facility. Ortec makes the high purity germanium, and there was 10 staff that ran that whole building from what I recall. And 8 of them were over the age of 60 manufacturing this high purity germanium. And so that's the industry. The industry started 40 years ago in its prominence with the, about the time RHOs were founded. And then now all these people are going to retire and leave the workforce. If you look at the Health Physics Society, that's Mr. Fong. I didn't hear a chuckle. It's Mr. Fong as a young JG, or was he a JG, right? Yeah. This was from the Health Physics Society website, and I'm not trying to say, look at these old people. That's not what I'm trying to say. I'm just trying to say, look at the average age of the people that are attending these professional enrichment programs, people that are attending, the people that are teaching these lectures, right, are, the average age is kind of up there. So to kind of look at health physics, to explain to you what's in a certified health physicist, I'll start at the bottom and say, what is health physics? And when someone asks me that's in science but isn't necessarily privy to like radiation as a health field, whether it's health physics or radiation therapy or whatever, I'll usually tell them that it's the study of ionizing and non-ionizing radiation, how it affects a person and the environment. And then you can contrast that with medical physics, where it's like for the benefit of the patient and the safety of the medical staff or something like that. But that's a pretty broad description, and so to be a certified health physicist, they break it down across 5 domains of practice is what they call it. So we've got measurements and instrumentation, standards and requirements, hazard analysis and control, operations, procedures and fundamentals in education, and an even distribution of these 5 categories and how you execute yourself as a professional in the knowledge, expertise, the core and subspecialty areas that are on the exam. That's what determines you to be a certified health physicist. You don't have to be a CHP to do health physics, but they will certify you as knowledgeable in all of the areas as a professional once you're a CHP. And so the domains of practice, I know that's really small, but this is what I have to do, is I look at a question and I say, where does this question of 10 points fall out? Is 2 points of it here, 3 points of it there? And so what ends up happening is we have a question like this, and even that's kind of small. This is an iodine uptake question. And so there's measurements and instrumentation where you're calculating the internal intake, or you're referencing the ICRP models for how an ingestion or inhalation travels through the body, both the intake fractions. You have standards and requirements, which is your regulatory criteria. So you have to be able to calculate committed dose equivalent in this question. I believe it was CDE, and apply the tissue weighting factors. You know, we know that, right? And then hazard analysis and control might be controlling the routes of exposure, so wearing a respirator and respiratory factors, but that also crosses over with regulatory criteria, because 10 CFR 20 is where your protection factors are located. And then this question also asks about the significance of radiation exposure, so applying it and being able to explain the various technical sides of a radiobioassay program, for example. And then finally, fundamentals in education. I usually attribute that to the justify your answer, explain your answer, or stating assumptions, because those can fall anywhere, but I like to put those in fundamentals in education. So when you're looking at this question and you have all of this criteria that you have to balance, we want to figure out what level of person, and I hate the timing of this slide because I'm not trying to say that Angie here is a just qualified candidate. She's definitely qualified, but that is a person who is just at the point where they're eligible to sit for the exam. So 6 years of professional level experience, and then the bachelor's degree as a minimum requirement, and then you can offset the professional time with a master's or PhD, right? And is adequately prepared to demonstrate, which means you can pass the exam. So that's what I just said there. So like I said, here's our core topics and our specialty topics. The core topics are on, you're gonna have to answer, there's 6 of those questions and you have to answer all of them, and they're 50 points apiece. And then the specialty topics are obviously listed. So testing these areas for competency is done through a review of the applicant's professional history, but a two-part knowledge exam. So the part 1 exam is held at computer testing sites now. When I took it, I drove to Savannah River site, but now it's at computer testing centers. And it's 150 choice, multiple questions. You have to get a 63%, and the testing centers emulate the TI-30X. Or what is it, multi-view? I don't know what the TI-34 is off the top of my head, but I'm used to the 30 or the 36. Part 2 is held concurrently across the country. It's usually on the Monday of the Health Physics Society, and they have proctors, but until you have a site, they say a minimum of 5 is a reasonable number of candidates, but if you are at a location where there's 2 CHPs within driving distance, you can usually get permission to set up a testing site with 1 person. And I almost had to do that a couple times in Japan for various people who were interested in taking the exam, and it was just easier to travel to Japan, or they wanted a reason to go there. And you have to get a 67% or better. And so if you fail, you can't take, if you get less than 300 points, then that means you didn't try to prepare at all, is what they're assuming. So you have to wait a year unless you're in the 6th year of your exam. So when I look at the exams, I ballot it, and so there's a form that I have to fill out, and I balance the domains of practice. And so what that looks like is I look at it and make sure there's no corrections that are needed. I make sure it's a quality question, make sure I'm not repulsed by it as a former person who took the part 2 exam. Is it too long, too short? Is it reasonable to grade, and then the validation scale is what breaks down 4 different categories for the question. And so things that we look at are level. At what professional level is someone going to experience this material? Are they going to experience this the first day of the job, or is it going to be something that they do after 10 years in a health physics job? How important is it? If someone is seeing this for the first time as a just qualified candidate who passes the exam, is it going to adequately judge their level of performance in health physics? Differentiation. If I was to go to a job and perform well at this health physics task, how well will it differentiate me from someone that is not so good at health physics or is not a CHP? And then consequence would be like the most serious consequence that would happen if I fail to understand this material. So I'm blanking on a good example, but catch me on the break and I'll think of a good example. But if you have a 1 score on level 1, 2, or 3, then we have to throw out the question. Like they won't even let it be, they won't even use it as a question if one of those is there. So common questions from applicants. First, like what's the pass rate? Part 1, 40%, part 2, 40%, straight from the HPS the CHP prospectus, 40%. And so I would attribute that to part 1, it's really easy to study for, and it's base level knowledge, but a lot of people just don't study. They just don't study, but it's, it's more reasonably achievable to pass that than part 2. Part 2 is people just don't know how to study. So, also, what's the deal with this professional report? Did anyone struggle with the professional report when they submitted for their CHP certification? Anybody? So, I'll skip past this. Let's catch me on a break if you want to submit a professional report. If you did a thesis or a non-thesis and it truly was independent and you weren't guided through it, then it's okay to use your thesis or non-thesis from your graduate degree. I've heard of people using dose estimates as long as it's a reasonably difficult decision-making regulatory referencing dose estimate, not a standard CDN, 1-hour entry to the reactor spaces dose estimate. I would say maybe a shielding survey would be a good thing. If I have an 8-page shielding survey where I'm installing a CBCT and I do a pretty in-depth analysis, that would be a good one. So they break down in the HPS prospectus what is not a good professional report, and rather than read through the list here, I would recommend the prospectus that's linked at the bottom of this page has really good information about the material that they want for the professional report. Studying for part 1, there's this book, Basic Health Physics by Dr. Bevilacqua. It's 900 practice problems, and they are phenomenal questions, and half of the CHP exam is part 1 is either from this book, or it's in this book, or the DataChem software, which is part 1 questions. There's 1,064, and what I did was 100 questions twice a day before the month I was going to take part 1. I was in graduate school during the summer, and I went to Savannah Riverside and took it. And I remember half of the questions were in the DataChem, half of the questions. And so, highly recommend it. And then the other half were like, well, I can eliminate it to these 2, and this one's probably the better selection. But just by virtue of elimination, I knew I had passed part 1. How do I study for part 2? The ABHP prospectus, I mentioned it once, I'll say it again. Pass part 2 exams, and then the exam solutions are on the ABHP website. If you go to the Health Physics Society website, which both links are in the bottom, you can find a Health Physics Society that they used to have solutions beyond the 1996 to 2001 posted on the HPS website, but I couldn't find them anymore. I have them downloaded. If you would like them, I can share it with you. But now they have replaced it, appears they have replaced it with something that Dr. Johnson and one of his former PhD students had worked, I believe a PhD student, I might be wrong on that, but they created a database full of new questions, and they're pretty good quality. So there's the questions bank, and then there's a solutions bank right there on the website. So go to that. And it says members only, so if you're not a member, hit me up. Maybe I'm not allowed to do that, so for the purposes of this recording, I want to say you have to be a member. And then the contemporary health physics, which is also part 2 questions with explanations that are way more in detail and of more quality than what you would find on the stock solutions from the ADHP website. Here's the formula sheet. That's the other thing I would recommend studying. When I look at the formula sheet, it used to be, I think, 4 pages. Now it's only 2 pages. So one, make sure you have the right revision. But when I look at it, I see different, I know this sounds weird, I see different colors. Here's what I see when I look at it. I see, here's the things that I need to like memorize in full and how to apply the equation when I'm sitting in front of a piece of paper with no other resource. I need to know what every variable is. One of them is highlighted because it has like 73.8 CE, I'm like, all these variables, I need to remember them. And then what's the 73.8? That means it has to be in specific units. So if you were to take the CHP without memorizing a different equation, you would have to know exactly what units to put in. And I put the environmental one on there because you need to be able to understand what all the values are that go into it. These are the things I say don't even worry about, because you either know it or you don't. You either know what an alpha particle range is, that it's going to be in centimeters, or you don't know, you don't know, and you just plug in a number. So there's really no reason to memorize it or understand it, because you should already understand it if you're trying to sit for the CHP. And then I put on the right side, notice that the variables I didn't color, because I think you need to know going into the CHP like what the variable is, but you don't necessarily need to know the equation to apply it. You need to understand the equation, you just don't need to study that in depth. And then one more resource I have is, I have a Brainscape flashcard deck that I created. Feel free to go, it's free to use. So it's on this link, you can get that later. And it has like the equations and how to apply them is specifically the good part. Because when you have an equation in front of you, understanding what values need to put into it is very important. So anyway, with that being said, if there's any questions, I'll be happy to take them. I hope you like to pick this slideshow. And thank you.